2.2 quadratic equation for C and D. In this subtopic, you will learn to recognize the types of roots of quadratic equation based on the value of the discriminant b squared minus 4ac. You will also learn to solve the simultaneous equation of linear and nonlinear forms involving two unknowns. For nonlinear forms, include terms that have square root which result in quadratic expression or powers that are not more than 2. Types of roots of quadratic equation. In general, a quadratic equation has two solutions that are called roots, namely negative b plus minus square root of b squared minus 4ac over 2a. Now, the value of b squared minus 4ac here, which determines the type of roots, is called the discriminant. So let's see what types of discriminant that we have. If b squared minus 4ac is more than 0, which is positive, the type of roots is real and distinct. However, if the discriminant b squared minus 4ac is equals to 0, then the type of roots is real and equal. And lastly, if the discriminant is less than 0 or negative, so the type of roots will be no real roots or in complex number. We'll now look at example 12. Determine the types of roots of the following equation. We have 4x squared plus 20x plus 25 equals to 0. This is a quadratic equation and we need to determine its a value, b value and c value. A is equals to 4, b is equals to 20 and c equals to 25. Why we need this a, b and c value? Because we want to find its discriminant. So discriminant b squared minus 4ac is equals to 0. Hence, the types of root is real and equal roots. Let's see the next example. We have another quadratic equation which we determine the value of a, b and c and we find the determinant which is more than 0 here. It's 41. So the types of root is real and distinct. And lastly, for C, we have this quadratic equation and we determine the value of A, B, and C and we find the discriminant which is less than 0 or negative. Hence, the root is no real roots or complex number. Example 13 here will show us the reverse type of question that we have seen in example 12 just now. The equation kx squared plus 3k plus 1x plus 4 equals to 0 has equals root. So as we can see, it gives you a quadratic equation and it gives you also the type of root which is an equal root. Hence, we can use the discriminant b squared minus 4ac equals to 0 to solve to get k. So solving this will give us two values of k, which is k equals to 1 over 9 or k equals to 1. Hence, the answer that we get is k equals to 1 over 9 or k equals to 1. Exercise 7 here will help you to know more about how to solve using this discriminant and types of root. In the subtopic 2.2d, you will know how to solve simultaneous equation of linear and nonlinear form involving two unknowns. For example, this equation asks us to solve these two equations, square root 2x plus y equals to square root x plus 1. This is the first equation. And y plus x equals to 4, another equation. We name the first equation as 1 and the second equation is 2. And then we get the third equation by moving x to the other side. So we will have y equals to 4 minus x. So we name it as equation 3. And then we solve it simultaneously by substituting the third equation into the first equation, and you will get something like this. From there, you square root both sides and you will get the value of x, which is equals to 9 over 4. And then you substitute back x equals to 9 over 4 into the third equation, and you will get the value of y, which is equals to 7 over 4. Hence, you already solved the equation where you get the x value equals to 9 over 4 and y value equals to 7 over 4. Now we move on to example 15. It asks us to solve these two equations. And first, we name the first and the second equation, and we get the third equation from the second equation when we move x to the other side. And then we substitute the third equation into the first equation to get something like this. And you already solved the equation where x equals to 4 and x equals to 1. So when x equals to 4, y equals to negative 1. And when x equals to when x equals to negative 1, y equals to 4. Here is exercise 8 for you to try and do by yourself. Please note that you may take some time to do these exercises, so please be patient and please do it very careful. Thank you.